All right, so let's look at some questions from the Module 3, Lesson 15 problem set. This lesson's titled Graphing Solutions to Inequalities, right? Yeah. But that's not really anything new for us. I've been asking you to graph the solution set to your inequalities even since like Lesson 13, and especially in 14. So really for us, Lesson 15 is just more of the same. More of the same practice of just writing, solving, graphing inequalities, just like Lesson 14. So I'll do a few of these questions for you to help you along. Let's see. I actually don't have this problem set memorized like I do some of the other ones, so I'm just going to pick some random ones. I'll start with number 1. Ben has agreed to play fewer video games and spend more time studying. He has agreed to play less than 10 hours of video games each week. Okay, so that sounds to me like it's going to be the limiting number in this problem. Remember, in each one of these problems, I think each one, there's usually this number that everything else has to be more than or less than, and that usually winds up being just like one side of our inequality by itself, and I call that number the limiting number. So I think that's going to be 10 in this one. On Monday through Thursday, he plays video games for a total of 5.5 hours. For the remaining 3 days, he plays video games for the same amount of time each day. Find T, the amount of time he plays video games for each of the 3 days. Okay, so there's some remainder of time after he plays for 5.5 out of the 10, and that remainder of time is going to get split evenly between the 3. So I feel like we're going to wind up subtracting 5.5. I feel like we're going to wind up dividing by 3. But we can set up an inequality so that that winds up being what we do. Ignore the fact that this says 14 here. We're doing PS 15. All right, so I guess the first thing I'm going to do is define my variable. And it told me in the problem it wants me to use T for like the number of hours he plays each day. So hours playing each day. And then since I know this is my limiting number, the whole total playing time has to be less than 10 hours. It says less than. That means strictly less than. That means no equal sign underneath it. So less than 10. And I make sure that the less than side of my less than sign is pointing toward where I'm going to put all the other stuff, all the amounts of time that he plays. And then, so he played for that 5.5 hours at one point. I'm not big on mixed numbers. I would either use an improper fraction or a decimal. I guess I'll go decimal this time. And then, plus he plays for 3 days for T hours each day, and that's the thing we're trying to figure out. So I think this is our whole inequality here. 5.5 hours plus 3 days of T hours each. That has to be less than the total of 10 hours that he agreed to play. So we subtract 5.5 from each side of the inequality, and we get 3t has to be less than 4.5. And if you were trying to think about how to solve this problem without setting up an inequality, I bet you would think, okay, well, let me just subtract the 5.5 from his total 10, and then what I get, I'll just divide by 3. And that's exactly what you wind up doing. It's just a matter of setting up an inequality first that gets you to use those steps. So I'm going to divide both sides by 3 here. And I get t is less than 1.5. So what's his name? Ben. Ben plays for less than 1.5 hours per day for those 3 days that they're talking about. And then we're supposed to graph the solution. I didn't leave myself a great space to do it, but I suppose I can do it right here. So since my solution set starts at 1.5, I'll graph a few numbers to the left of that and a few numbers to the right of that. So I guess I should start maybe at like -2 or something. -2, -1, 0, 1, 2, 3, 4. We'll do that. So -2, -1, 0, 1, 2, 3, 4. And then I need to put a circle right at 1.5. So that's right here between the 1 and the 2. And I'm going to leave that circle open, meaning I'm not going to fill it in, because 1.5 itself is not a solution to this inequality. If you let t be 1.5 and you put it back into this inequality, this side would equal 10. And he said he would play for less than 10 hours, not equal to 10 hours. So we got to use an open circle, and we're going to shade all the possible time to the left. And really, I'm actually going to just stop my shading right here at 0. Because he could play for 1.5, anything less than 1.5 hours. He could play for 1 hour, half an hour, 2 minutes. You can't really play video games for -1 hour or so. So I'm not going to shade on the negative side. All right, let's see here. How about I'll do the odd ones? That way I'll leave you the even ones. So I'm going to skip to number 3. It says Sally's bank account has $650 in it. I don't know yet, but that already sounds like it's going to be the limiting number in this problem. Every week, Sally withdraws $50 to pay for her dog sitter. What is the maximum number of weeks that Sally can withdraw the money so that there is at least $75 remaining in the account? Okay, so judging by this problem, I do believe this is going to be the limiting number. I'll write lim num next to it. And I see the words at least. And so what does at least mean? It means that there could be more than $75 still in the account, or there could be exactly $75. 75 is at least 75. So I think that this means that I should be using the sign that says the money in her account must be greater than or equal to 75. So let me do the first few things I'm supposed to do. I got to define a variable. I'm going to put my limiting number down. I'm going to put my inequality sign in, and then we'll go from there. So it looks like I'm trying to solve for what is the maximum number of weeks. So I think I'm going to set a variable w to stand for number of weeks. And I'm going to put my greater than or equal to sign and my limiting number down, which was 650, right? Yep. So all the stuff over here is going to represent like the remaining balance in her account after she, nope. I just realized I'm doing this wrong. That's all right. We all make mistakes. Another example of Mr. Thomas messing up. So if you're messing up, don't feel bad. Now I realize that this is actually the limiting number, not this. I don't want to cross the number out because I want to still be able to read it, but I'm going to cross out lim num right there. And I'm going to write lim num for this one now that I think about it. I thought this was going to be the limiting number because it's how much money is in her bank account. And often in these problems, the amount of money that you have on you or how much money is in your bank account limits what you can do. It limits how much money you can spend. And so I kind of jumped to a conclusion there. But now I realize that in this problem, they want to put a lower limit on the amount of money in her account. They want, if this is her account, right, like this money here, they want this lower limit here that says, we don't want this account balance to drop below 75. It can be anything above. So yeah, I'm going to change. I'm going to say that everything in this inequality over here that's going to represent how much money is in her account has to stay greater than or equal to 75. And she starts with $650 in her account. And then she's withdrawing, which means like taking out or losing $50 every week. And so as the weeks go up, she's taking $50 out each time. This number is going to go down. We're going to solve for what W can be so that her account balance is still over 75. Also, I'm going to fix this here. I accidentally worked in the question 2 box when this is question 3. So I am going to subtract 650 from both sides of this inequality. Oh, and good, we're going to get to something that we haven't seen enough of in class, to be honest. When I subtract the 650 from this side, since there was a minus sign in front of this 50W, I got to make sure not to lose that. It's got to come down to right there. And so I've got negative 50W is greater than or equal to, well, 75 minus 650. If this said 50 minus 650, then I would know I'm at negative 600. But since I have an extra 25 up here, I'm going to be at negative 575. All right, and now I have to divide both sides by negative 50. I want to get this W by itself, so I divide by this number that's in front of it, and that's negative 50. So divide by negative 50, divide over here by negative 50. And so that leaves me with just W on this side. And then, well, thinking about how many times does 50 go into 500, that'd be 10. And then one more 50 would get me to 550, so that's 11. And I'd have 25 left over, and 25 is half of 50. So I'm pretty sure this is going to be 11 and a half, or 11.5. And since I did a negative divided by a negative, that makes this positive, which we should have known it was going to come out positive because you can't have negative weeks, right? If you got a negative answer over here, you have to think about the context of the problem and be like, wait. So this inequality sign, though, that used to say greater than or equal to, because we divided both sides of the inequality by a negative, has to switch and say less than or equal to, which also makes sense because she's losing money in her account every week. And so she's only going to have more than $75 in her account for like week 1, she still will, week 2, week 3, week 4, all the weeks that are less than or equal to 11.5. It wouldn't make any sense if this answer said weeks have to be greater than or equal to 11.5, because then that would say that she doesn't have $75 in her account for the first 11 and a half weeks, and then on the 12th week she does, and on the 13th week she has $75 or more. And that doesn't make any sense if she's losing money and for her to have more money later down the road. That's backwards. So here's our solution. W is less than or equal to 11.5, but if she's taking out $50 every week to pay the dog sitter, I'm going to assume that she's paying that dog sitter like once per week, like maybe Friday afternoons or something. And so if she was going to take out that money, I guess halfway through the 11th week, that means that she still has the money that she needs. She still has over $75 in her account on the 11th week, but then not on the 12th week. So really we could say W is less than or equal to 11, right? So then we just don't even think about the half week part or the 12th week. And so I can write a little conclusion that says she will have at least $75 in her account. What's a good way to word this? I could say for any weeks less than week 11 or up to week 11, or I could say for the first 11 weeks. There's lots of different ways you could say sort of the same thing. And then I got to graph this. So there's a couple different ways you could graph this. You could graph starting at 11 and a half and then shading the things to the left. But because I'm thinking of it as she pays the dog sitter once per week, there's really no like half week to consider here. So I'm going to start my graph at 11. Either way would have been correct, I think. I think you could debate either which one is the correct way to do it, and both would really be right. So I'm going to mark a few numbers to the left of 11 and to the right of 11. So how about we can start at like 8, 9, 10, 11, 12, 13, 14, 15, and then I'll put a circle on 11. And this time I'm going to close the circle. I'm going to fill it in because I've got the equal bar, and 11 weeks is a solution. If I put 11 into my inequality, it would still be greater than or equal to 75. And then I'll shade in this direction. All right. And lastly, I'll do question 5. I'll turn my paper over so I'm actually working in the question 5 zone. And let's see what question 5 says. Is it on the screen? Yep. The length of a rectangle is 100 centimeters, and its perimeter is greater than 400 centimeters. Okay, so that means the width is going to have to be at least 100 as well, because if I add up 4 sides of 100, 100, 100, okay. Henry writes an inequality and graphs the solution below to find the width of the rectangle. Is he correct? If yes, write and solve the inequality to represent the problem and graph. If no, explain the errors Henry made. So I'm thinking about a rectangle, and it says the length is 100, so that means the length on the other side also has to be 100. Oh, this is off the screen. Let's see. And if the perimeter is greater than 400, well, and these are the width, that means that 100 plus 100 plus W has to be greater than 400. And so just looking at that, that means that this has to be at least 100 and this has to be at least 100 for this to work. And I'm looking at his graph, and he's showing me solutions that are less than 100. So I don't think his thing is right. I'm going to go ahead and write an inequality and solve it and show how this should have been done correctly. So I'm going to draw a little diagram here, the same diagram I just drew on the other paper. 100, 100, and then the width, and then the width. W will be my variable that stands for the width of this rectangle. I'll just write width. And then the limiting problem, or limiting number in this question is 400. They want the whole thing to be greater than 400 or more than. So let's write an inequality symbol so that the stuff to the left of this sign will be greater than this 400 that the thing's supposed to be. And then we have 100 plus 100 for the two lengths, so I'll just write that as 200. And then W plus W for the two widths, I'll just write that as 2W, save myself a step where I have to combine the like terms. And then I'll subtract 200 from both sides. And I get 2W has to be greater than 200. And I'll divide both sides by 2. And I get W has to be greater than 100, which is, exactly what I thought. So I'll write the width must be more than 100 centimeters. Let's use units in our conclusion. And so I'll fix his graph. It's mainly right. He marked off numbers around 100. So I'll start at 96, I guess, 97. My numbers are close together, sorry. 99, 100, 101, 102, 103, that's good enough. And he put a circle on 100 like he was supposed to, and he closed it, filled it in like he should. No, actually not supposed to on this one. I don't have the equal bar underneath my inequality sign, so 100 is actually not a solution on this one. We need numbers that are greater than 100, not just 100 itself. So this should actually be an open circle. So I'm going to draw a big old circle there to fix my other error. 2 big errors in this video, wow. And then instead of how he shaded the numbers to the left, the smaller numbers compared to 100, I'm going to shade the numbers to the right, the bigger numbers. All right, well, there you go. I'll let you guys do questions 2 and 4 without my help.